Hello everyone, welcome back to our second topic of this unit. And as we mentioned before, this unit we are going to talk about the polynomial and the rational function. So today we are going to start talking about graph of polynomials. And since graph of polynomials actually has a lot of features, so we are going to separate this topic into several small topics. So today we are going to focus on there's a new word called end behavior. So what does that mean? So basically, end behavior, as you can see in front of you, they're all different kind of graph of polynomials. As you can see, sometimes the graph both going down, going up, or one is up or one is down, and sometimes one is up, one is down, but for different directions. So what we are going to do is we are going to focus on end behavior is basically we analyze how the graph changes when x is getting bigger or when x is getting smaller. So that will be something we are going to do, and we are going to analyze the graph of polynomials. So this is just a quick example to give you the idea. So we are going to use x to predict how y changes. But today we are just going to see the very basic graph of polynomials and to see some pattern we might notice. Okay, so to start the lesson, we actually gonna see a lot of simple graph. And as we mentioned yesterday, when we look at the polynomial, the very simple way is we have variable and also their exponents must be whole number. So the simple polynomial function can start as y equal to x. Then we can just increase the number of exponents to x squared, x to the third, fourth, and we can just keep going forever. However, I want to let's just check this graph together to see if you notice some patterns here. So as you can see, y equal to x is just a linear function as we mentioned before, and past origins it goes up and down like this. For x squared is like a u, and for x to the third power is a curve, but the trending is very similar to the y equal to x, is going up and down. To the fourth is like a u, but this u is is wider u compared to the x squared. Fifth, same thing, similar to third, but it's like a wider. The range is the trend for the curve is more mildly going up and mildly going down. Same thing to the sixth, and it's like a U again, but again compared to the fourth, even wider. So and for the seventh, same thing, it's still going up and down, but is wider. It's more mildly going up and going down. So you can definitely pause the video here to think about what pattern do you notice, and probably you already come to the conclusion as we are going to share. So I guess you already, I hope you already paused the video and think about what you'll notice. So for this one, we actually notice for exponents, one is odd number, for example, 1, 3, 5, 7. For all this one is all like this. For the odd exponents. So when exponents is odd, like 1, 2, 1, 3, 5, 7, is going up and going down. And for even exponents, it's always like this. It's both going up, right? So this kind of behavior, so again, the reason we analyze this, we are going to use x, how x changes, to predict how y changes. That's basic end behavior. So that's a very basic one as we see the graph. However, some students might ask, is that always true like this? It's going to change if I change the function. But based on what we see here, for the basic function like x squared, we can simply give this kind of conclusion. So we are going to change this one to the words to see this. So I'm going to use this blank space to say that. So when we see y equal to xn, n is, oh, sorry. By the way, n just represent the number of exponents. Then when we see y equal to x to the nth power, n is odd exponents, then our conclusion for how the x changes is going to be like this. So I want you to focus on this part. So when we analyze this one, meaning when x getting bigger, so you can see when x to the right side, y is increasing, go like this. When x to the left side, y is decreased, going down. So when we do that, when we see this, we say as x increases, y increases. So this is like the right side. And for the left side is x decreases, y decreases. This is like left side. So we can actually copy exactly same thing, but this time when we see y equal to xn, but n is even exponents, and we can come to exactly same conclusion. But this time the conclusion will be as x increases, y increases. However, this time, oh, sorry, whenever it's coming to the bottom of the page, it's always go like this. But this time, as we mentioned, as x decreases, which is the left side of the graph, what happened to the graph is, because the graph is actually look like a U, so no matter x increases or decreases, y is always increases. And that's it. So that's actually the basic conclusion we got from this. So let's just quickly check here. Then we can see, so based on what we see on the graph here, we are going to just predict the very draft graph for x to the 8th power, x to the 9th power. So I'm going to leave this question to you, and later I'm going to list this one as exit ticket, so let you think about it. Again, I strongly suggest you just not to use calculator and think about it, how the graph to the x to the 8th power and x to the 9th power changes, or just, the very basic graph, how does it look like? You can also use this kind of the word to describe the end behavior for this. So I just want to readdress again. The one I just mentioned for this part, this is how we analyze the end behavior. When x increases, what happened to y? When x decreases, what happened to y? Okay, thank you so much for watching this video. This is just very initial introduction for the end behavior. We're definitely going to introduce more lessons for that, but just use this one as foundation to help you to start understanding this topic. Thank you so much for watching. I hope this video is helpful. Take care, everyone. See you soon.